So in today's lesson, we are going to be looking at algebraic proofs, and this is grade 8 to 9 topic. Also, our only goal is to solve any algebraic problems. Okay, any algebraic problem, you'll be able to solve it. Now, question 1. For question number 1, prove algebraically that the sum of any two odd numbers is always even. That means any two odd numbers. What are odd numbers? They are numbers that cannot be divided by 2. If I say 2 divided by 2 is equal to 1, because 2 is an even number. But if I say that 3 divided by 2, that will be 1.5. 3 is not an even number, but 2 is an even number. Therefore, 3 over 2 is equal to 1.5, which means 3 is an odd number. Now, how do we work this out? Let the two odd numbers be represented as 2n plus 1 and 2m plus 1. The reason we have done this is that, you see, any number multiplied by 2 becomes even number. If I say 2 times 3, even though 3 is an odd number, then 2 times 3 becomes 6, and 6 is an even number. Now, if I say 2 times another odd number, let's say 7, then that will give me 14. You see, 14 is an even number. Now, anytime we multiply any number by 2, it gives me what? It gives me even number. By the time you add 1 to any even number, it becomes an odd number. That is why we say that we should let the first one be 2n, which is an even number, then plus 1. Plus 1 means because we added 1, it has turned to an odd number. The same way, if I say let's have 2m, whatever m is, even if it is even number, multiply by 2, it will still remain as even number. Or even if m is initially an odd number, multiply by 2 will still give me even number. Now if I say plus 1 we make it to turn to an odd number. Okay, so that is the reason why we follow the very first step. That's why we follow the very first step here, and I hope that step is clear. So now next step we have to follow is that we will sum 2m plus 1 and 2m plus 1. Let's sum it. Why do we have to sum it? Because in our question, the question says prove algebraically that the sum of, that means the sum of any two odd numbers. So initially our first odd number is this, and the second odd number is this. So the sum, meaning that we are going to add the two together. So when we add it, it means 2n plus 1 plus 2m plus 1. That means I have 2m, 2n, 2m, then 1 plus 1, okay, the 1 here plus another 1 here gives me this 2. Now, if I factorize 2 out of all of these 3, that means I factorize 2 out here. So inside the bracket, I will have n plus m plus 1. Since it is divisible by 2, you see, because when I have 2 into bracket m plus n plus 1, this number is divisible by 2. I can divide it by 2, okay, which will still give me a whole of m plus n plus 1. That means the whole of this is a even number. Since it's divisible by 2, the sum is even. Therefore, the sum can be assumed to be even. Because I told you from the beginning, any number multiplied by 2 will give me even number. So now the whole of this number, outside of it we have 2. So 2 times anything inside will still give us a even number. That is very clear. Thank you. So let's go to the question number 2. Okay, We'll go to question number 2, which is this one. It says prove algebraically that the product of any two consecutive integers is always even. Any two consecutive integers. So consecutive integers means, let's say I have 2 now, is an integer. The next integer is what? Is 3. The next integer is what? Is 4. The next one will be 5. All these are consecutive integers. 2, 3, 4, 5, as it follows each other. Okay, so all these are consecutive integers. Now, because we need to prove algebraically that the product means to multiply any two consecutive integers is even. Now let's go and check it out now. Let the two consecutive integers be n. The first one be n, and then the second one will now be what? N plus 1. It's just like saying 2, then 2 plus 1 equals to what? Equals to 3. So we could pick this one and this as the first and second integers. Okay, so this step is clear to everyone. Now, the next step we will take says the product, because according to the question it says the product. The product means to multiply. So we are going to multiply the two integers, which means n into bracket n plus 1. Okay, in any, that means I can actually do is equal to what? N squared plus n. Okay, n squared plus n. If I multiply that, open the bracket. However, in any pair of consecutive integers, one must be even. You know that? According to what we have here now, you see 1 is 2. So the first one is what? Is 2. So let's say the first one we pick is 2 now. So I have 2 square here plus what? 2. I will still have what? That is 4 plus 2 equals to 6. You see, I still have the number as even, so it's even. So let's use another set of integers like our n, then n plus 1. Let's say the first n is 3, and the next one will now be n plus 1, which is what? 4. So if I have n into bracket n plus 1, which is the same thing as n squared plus n, that means if I put my n is 3 here, so 3 into bracket, what is this one? 3 plus 1 equals to what? 3 into bracket 4, which is 12. The same thing will happen here. If I have n squared, which is 3 squared plus 3, which is equal to what? 9 plus 3, then the answer is also 12. So you see, the 12 we got are both even numbers. Therefore, we have been able to prove this statement. That is exactly what this one means. So this is even. Okay, that is perfect. Now let's go to the next question. Let us go to number 3 now. Number 3, which says prove that the sum of the squares of any two consecutive integers is always an odd number. Okay, it's always an odd number. Prove that the sum of the squares, so we are working with the square of any two consecutive integers. So the first thing is, let's determine our integers. Okay, the first integer I told you the other time, let it be n. Okay, then the next integer will be n plus 1. At this point in time, I don't need to explain this to you again. So if the first integer is n, then the next one will be n plus 1. And that is very, very clear. And why we do this one is very clear to everybody. Now, step 2, write an expression for the sum of the square. Why do we have to write an expression? It says, prove that the sum, so the sum of the square. So that means we square what? We square the integers. And that is why we have this one. We square the integers n squared. Then the next integer, which is n plus 1, try to square it. So we square it and then we find the sum. We add it together. And that's how we have this state. Okay, that step done. Okay, I believe it's clear to everybody as well. Now, what's the next thing now? Step 3 says expand the second square. How do we expand the second square? We're talking about this one. Now we have to expand that second square. That means n plus 1 square is equal to what? N plus 1 into bracket n plus 1. That is how to expand. And you just have to say that n times n will give me what? N squared. Then n times 1 will give me only 1n. Then 1 times n here will give me only 1n. Then 1 times 1 again will now give me plus 1. So finally, what we can have here is what? N squared plus n is 2n plus 1. Perfect. And that is how we got these steps. Okay, that's the next step gotten. That is very clear. All right. I hope you are following this step by step. It's very easy, right? Now, we need to substitute back now. By the time we substitute back, that is looking at this stage now, n squared is this one. Then our expansion that we did is this. By the time we did that one, we have substitute. And then the next thing is that let us look at our question again. Prove that the sum, I'm going to remove 2 for us to see. Prove that the sum, so we've done the sum, we've done the square, we've added it. It's always odd number. So we are going to prove how it is odd number now. Step 4, combine the like terms here. So when we have n squared plus 2n plus 1, there are some terms that are the same, looking alike. N squared and s squared looks alike. That is 2n squared. So we have this plus 2n. It does not have power, and that is why it is standing alone. It doesn't have power. Then plus 1, which is the last figure here. So we have this now as our answer. Now we have to show that this is actually going to be odd number. How? We can actually factorize it out by saying, look at this step now. I'm jumping up. I brought out 2. Okay, I brought out 2 from each of them. Let's look at it together. From this and this, they both have 2. So I brought out the 2 here. That means I have n squared plus n in the same bracket now, plus the last one. I told you when we started that whatever number you have, even if it is even number, by the time you add 1 to it, it becomes an odd number. So meanwhile, this one is a even number. Okay, this one on its own is an even number because any number multiplied by 2 is already even number. By the time you add 1, 2, an even number, it becomes an odd number. So this is of the form even number plus 1, which will give us odd number. Okay, so since the expression is always of the form 2n squared, 2 into bracket n squared plus n plus 1, which is an even number plus 1. Therefore, the sum of the squares of any 2 consecutive integers is always an odd number. I hope that explanation is very clear. Thank you. So now I'm going to do something. What I will do is to test yourself on these ones. I would like to test yourself, okay, and then put the chat comment in the comment section if you get the answer correctly. But if you would like me to solve it with you, or you want to book a one-on-one session with me, please kindly reach me on WhatsApp with the number. This is my number, plus 234 810 32 77436. This number will make you to land on my page, WhatsApp page, so you can book one-on-one session with me. If you try this and you didn't get it right, and you think you are not getting it right, or you didn't get your answer, let's go to this next question. Test yourself. What do I do? Prove that the sum of 3 consecutive odd numbers is always a multiple of 3. So try this one as well. If you're able to do this one, that's a kudos to you. That means you are doing very well. If you would like to get a premium question and answer, so you can also reach me on the same WhatsApp number, or you can use my seller's account. You see it in any of the the link below, or in the comment section. You just check around, you see the my seller's account there, you can actually purchase a complete grade 8 and 9 premium past question and answer, which is going to be very easy for you to go through. Thank you. Just like I said, you can reach me on WhatsApp in this case. So if you have any question, let me know in the chat box, okay, or you can reach me on this number. So till I see you again, thank you. Bye bye.